Hello, this is Mr. Collier, and today we're doing geometric series, okay, which means we're going to be adding terms in a geometric sequence, basically. Okay, so this is these numbers are being multiplied by 4 each time. R equals 28 divided by 7, which is 4. So we can simply use the formula from the booklet. There's two versions, but it doesn't matter, either one works, so I don't really need the two versions. U1 equals 7, so we just substitute in the formula. Sum of the first 8 terms is a first term times, be careful, this is negative, or if this is a fraction, then we'll need to put it in brackets, so be careful of that. So we just substitute this in, and it gives us the sum of the first 8 terms, okay? So let's do that. Let's make a fraction first, then do 7, bracket, 4 to the power of, it should be 8. In this case, minus 1 divided by 4 minus 1, which is just 3. So it gets pretty big pretty quickly. It's 152,000. Now, by the way, no need to round something like this. This is an exact number. It would be pretty weird to round this, actually. So no need to round it. Let's look at the next one. When Kenzo starts Bright Academy, the school fees are 2.5 million yen. The fees increase by 2% per year. Okay, alright, write down the common ratio. So they're increasing by 2% each time. That means you're multiplying by 1.02 each year. Okay, calculate the school fees in year 6. Well, we've got U1 equals 2.5 million. So the school fees are just U6. And recall that's 2,500,000 times 1.02 to the power of 6. So let's do that on our calculator. 1.02 to the power of 6 times 2,500,000. So it's about 2.8. Okay, and in reality, they'll probably round this number rather than charging people like that extra 5 cents. Okay, so maybe I'll just round it there. Calculate total school fees paid for 6 years that Kenzo attends the academy. That's S6. And the formula is simply first term, that's 2,500,000, times R, which is 1.02 to the power of 6 minus 1, divided by R minus 1. Okay, and let's go here. Okay. Alright. And the denominator. And we get, is that 15 million? Yes, okay, that makes sense. 15,770,302. I'm going to round it. I guess on IB exam they would tell you to round it to a certain amount anyway. Let's do one like this again. This is the second term, U2, and the fourth term. And recall to get R, we can do, we could do, so these are two terms, so you can say the second term is 6 times R twice, so R squared equals 24, R squared equals 4. So R equals, it says all terms are positive, that's a good thing to note, so we just do the positive square root, and we get R equals 2. Alright, and the first term, to get the first term, well, we've got 6 here, and then R is 2, so we can just divide by 2. So U1 is simply 3. And to get the sum of the first 10 terms, once we have this information, we just use the formula. It's the first term times R to the power of n, the whole thing minus 1 divided by 2 minus 1, which is easy. That's just 1. I don't even need to type that into the calculator. 3 times 2 to the power of 10 minus 1, and that's it. 3,069. Alright. Next one is kind of interesting. When you bounce a ball from a height of 81 meters. So let's draw this picture. So that means it goes down 81. Each time it rebounds 2/3 of the distance before. Okay. So it bounces up 2/3 of that. That's 2/3 of 81. If you multiply that, 81 divided by 3 is 27. Times 2 is 54. Okay, so you go up 54, and then the ball comes down 54. And then the next time, you're going to have this up and down as well. Ball goes up, then it comes down. 2/3 of 54. Well, 54 divided by 3 is 18, times 2 is 36. So this goes up 36, down 36. Okay, and it keeps going forever. Technically, when you do this, the ball has an infinite number of bounces, so it just keeps going. But so if we look for the maximum height between the 5th and the 6th bounce, so we'll define the bounce as when it hits the ground at this point. So let's call this first bounce, second bounce, third bounce, fourth bounce. Okay. So we'll just use the formula. We got U1 equals 81, and then U2 equals 54, and so forth. So the R value is 2/3 because we're multiplying by 2/3 each time. So we just want U5, right? U2 would give us this height, which is the second bounce. I don't know what happened to one of those lines. Okay. Yeah, so U5. So we'll take the first term, which is 81, times 2/3 to the power of n minus 1, and work that out. So I need 81 there. That's 16. So 16 meters is between the 5th and the 6th bounce. And then we need the total distance traveled, but we have to be a little bit careful with this because here we got 81, and we've got 54 twice, and we've got 36 twice, and we got the next number twice. Every number's doubled. So you can think of it as two different series. One series starts with 81. All right, let's just do 81 plus 54 plus 54 plus 36 plus 36, right? Plus dot dot dot, which is like 81 plus 2 times the sequence 54 plus 36, and so forth. So we just need to find, use a formula on this part, the series. Okay, so 81 plus 2, and that's got a U1 of 54 and an R of 2/3. Alright, so we're going to use our sum formula is going to be 54. Now this, when you put in your calculator, you need to put 2/3 in the bracket, and what's n in this case? So total distance till when it strikes the ground for the 6th time. Alright, so that's going to go up to 6. So that's going to be 6 minus 1. Oops, sorry, 6 minus 1 over 2/3 minus 1. Okay, so let's do that on the calculator. You got 81 plus 2 bracket and 54 bracket and another bracket for the 2/3. Just be really careful about the brackets. 6 and then a minus 1, and the denominator is 2/3 minus 1. Double check before we click enter, make sure everything's okay. 376. Okay, 376 is a lot of, that's a lot of distance there, right? I guess 370 figures, it would be 377. 377 meters.